All right, hello, my wonderful students. This is part three of our third foldable. We have a few. We're actually gonna do all four of these because they actually don't take that long. Makes it a little bit easier to figure out. And then we have our quintic, our first quintic root, which is actually gonna be easier than you think. So, all right, so we're gonna start off with a quartic root, which is the quartic root. So the fourth root of parentheses m minus n to the fourth power. But just like the cubic root was and the square root was, if you have a square root of a square or a cube root of a cube, similarly, if you have a fourth root of a to the fourth power, x to the fourth power, these also reduce and just gives you x. So this is actually very easy because we have a fourth root something to the fourth power. So what's left over is just m minus n. So that means that's actually it. So n minus n, so therefore m minus n is our only quartic real root of the quartic root of m minus n to the fourth power. Cha-cha! The check's just because I felt like that box was a little bit narrow. Just wanted to add something a little extra pizzazz. Alright, so now we're going to go to this function here. We have the square root of 36x squared y to the sixth power. Okay, so once again we're doing with squared root, right? So we'd have 2. So I know by looking at my cheat sheet that 36 is actually the same thing as 6 times 6. X squared is already like where we want it to be. We want it to have 2. Let's multiply here. And then our y to the sixth power can be rewritten as, we can break this down. I mean, we can literally break this down because let's do a little side note again. Side note. Y to the sixth power is equal to y times y times y times y times y times y. But we need to group them in pairs. So we have 3 pairs. So this would actually be times y squared times y squared and times y squared. So we have 3 sets that we're actually going to pull out. Okay, so alright, and then we need to combine this set here so that we have it. So we're going to take our square root, and we're going to have 6 squared, because 6 times 6 is 6 squared, times x squared, times our y squared, times our y squared, and times our y squared. We're just basically, just combine these ones and all these just came down. So now we know what we can pull out, because this thing reduces each of these 2's, and we're left with 6, this is the absolute value by the way, x, and then y, which can be written as 6x y cubed. So therefore 6xy to the third power is our only real square root of, and our function for, or sorry, our radical expression is the square root or radical 36 times x squared times y to the sixth power. Alright, let's go ahead and move on to this next one over here. These ones we have the dreaded fractions, which I know you guys love fractions. So as you can remember, whenever you have a fraction inside a square root, you have to actually perform the radical to both. The easiest way to show this is to just rewrite the fraction as the radical on both. So we have the quartic root of x to the fourth, which comes out really nicely over the quartic root of 81. So I know I just showed you guys the cheat sheet for quartic roots, but I know this one's going to come out really nicely and just be x on top Remember, this is going to be the absolute value because it is a quartic root. It's an even root, and this was given to us. And then the pesky 81. So if you look at your cheat sheet here, which is all the way up here, we see that the quartic root of 81 is plus or minus 3. But since it was given to us, this quartic root was given to us, so it's an even root. We're going to get the absolute value of that, so it's just going to be a 3 inside. So our answer is going to, the absolute value of this is just going to be equal to x over 3. So now we have therefore, comma, x over 3 is our only real root. Sorry. So it is a real root, but it's a real quartic root. Or if you want to write fourth root, you can. Oh my god, I was writing quartic root. I'll put fourth here if you want to put fourth instead. Fourth root of, and our original function was the fourth root of x to the fourth over 81. I'm going to start writing these here because when we have fourth root, fifth root, sixth root, you know, it's better to say fourth root than, well, it's not better. It just, I guess it's better vocabulary to use quartic, but fourth root makes it a little easier to see. All right, so now we have our fifth root of 243 times x to the fifth, y to the 15th. Okay, so just like we did on the other ones here, we know that, little side note, if we have the fifth root of x to the fifth power, these reduce and we're left with just x. Since it is odd, if the number inside is odd, we're going to get an odd number on the outside, but luckily for us, none of these are odd, so we're going to get an even number. So I know that 243 is actually the quintic root, or the fifth root of 3 to the fifth power. I know that just because I know that, because I know that the fourth root, or the 3 to the fourth power is 81, but I know that 3 times 81 gives us 243. So it's just something, if you guys want to create a cheat sheet for the fifth power, it's actually really easy to do. You just plug it into the calculator and put 1 to the fifth power gives you an answer, 2 to the fifth power gives you an answer, but I'm not requiring that because these are going to be rare, but they probably will happen, and they will be usually as easy as these. I don't really recommending, you know, I've been going up to 10, so I went, for the squares I went up to 20, and for the cubes I went up to 10, the fours went up to 10, but for the fifth power, I wouldn't go really higher than 5 because I doubt you'll see any numbers that are really bigger than that because it's going to be really, really huge. And I can give you an example in another video, but this one, I just want to finish this one here. So, like I said, this is already in the fifth power like we want, so we're just going to leave it as x to the fifth. But we have this y to the 15th. Instead of breaking it down to, y, all the y's out, 15 y's together, we're just going to divide this by 5. It's going to tell me how many y fifths I'm going to have. So I know 15 divided by 5 is 3. So that means I'm going to have 3 y to the fifth powers. And then you can see that. Because if you have 5 plus 5 plus 5, it equals our 15 that we have there. Okay, so now we can go ahead and start taking things out. Since we have this here, we can actually reduce all of these out. And we're left with 3x, and then y times y times y is y cubed. So this is going to be our fifth root. So now we go, therefore, 3xy cubed is our only real fifth root of, or quintic, fifth root of the fifth root of 243 times x to the 5th times x or y to the 15th. Another little pizzazz check just for fun. I'm actually going to put this one in color, see how many people do that. Little pizzazz check right here. Very, very beautiful. I'm actually going to, if you were watching this video too, you know, I just want to do something a little different just so you guys can see. But right where my finger is here, I know my nail's a little, I smashed my nail. So right where my finger is here, draw a little happy face so I know you actually watched the video, so I can see that you were actually paying attention to what we're supposed to do. Okay? Thank you guys. Bye.